You're welcome to this episode. This is Solomon once again at Solo for Math. Today we are going to look at operations in O-level mathematics. Operations. What is an operation? We are going to look at the rules for combining or relating two elements from a given set. For example, when they tell you to add, when they tell you to subtract, when they tell you to multiply numbers, these are just basic rules that we consider. For example, when you're given something like 2 plus a 1, you ideally know that they're telling you to raise a 2 by 1 or increase a 2 by 1, giving you a 3. When they tell you to subtract 3 minus 1 or a 1 from a 3, then you know they are telling you to reduce a 3 by 1, giving you a 2. So basically this is what an operation means. It is a defined rule on two numbers, just relating any two numbers. So the operations we're going to look at are not these, but they are modified operations, if I'm to say. And let's look at examples. Example number 1. If you're given something like x star y equaling to a square root of x plus y, this is the new operation that we are talking about. We shall use, or they can use, different signs to represent operation. Like a sign for addition is this, a sign for multiplication, a subtraction is this, for multiplication it is this. Now here, whichever sign we use, we shall define it. It is defined because it is not these are common operation. We have to define it. So its rule is this, like when you're given x with this sign in the middle, then you know the operation you're going to do on those numbers is this: get the square root of the sum of the numbers. For example, if you're asked to find 1 star 2, what does it mean? This one means that the operation is equal to a square root, because we said this is the operation that is given. Don't think about anything else, look at what is defined, because we don't know this operation as maybe addition or multiplication, but its rule is given here. So like if this is our our x, and this is our y, we just feed it here, compare the two. This is x, this is y. So when you compare the two, this is 1 plus a 2. And this one will give us a square root of 3. We can leave it there. If it was a perfect square root, then we would get the answer. Alright, let's look at another example maybe. Example 2. If they tell you to find just a continued example of this. If you're given, let me say this was Roman numeral 1, this is Roman numeral 2. Find 2 star 7 using this very operation here. So from this operation, we know that x star y is defined as a square root of of x plus a y. Now if we have 2 star 7, This is like our x, this is like our y. So when we substitute here, this will be square root of 2 plus 7, which is equal to square root of 9, which gives you 3. Okay, let's look at number 2. If you're given an operation like m, they can use different signs. Let me use this, as long as they define the rule for that operation. Maybe if it is equal to m squared plus n squared. So if they tell us to find, let me say this is okay, they tell us to find Roman numeral 1, maybe 3 star 1. This is not a star. The operation is the sign is different, telling us 3, that arrow 1. So we just remember what is this operation meaning. We go back to this, what was given. It says m arrow n is equal to m squared plus n squared. So this is like our m, this is our n. So we just come and substitute here. So it means that 3 arrow 1 is equal to m squared, which is our m is a 3, so 3 squared plus n squared. Our n is 1, so 1 squared, and this gives us a 9 plus a 1, giving you 10. So in other words, when you're given an operation, go back to what does the operation, what is the rule given for that operation, and then you work it out. Let's look at another example. If you're given a, they can use something like this: a that b defined as b to power a. Then they tell you to find, let's say number 1 is 1, it is 1, 4. Maybe Roman numeral 2, it is 2, then 1, 4. Roman numeral 3, maybe it is 2, 3. Let's have this, let's do this, the solutions. So Roman numeral 1, they want us to find 1 operation 4. So looking at our operation back here, how is it defined? They told us that a operation b is equal to a b power a. So just find out what is your a. This is my a, this is my b. So it means that this one will be equal to b. What is a b? A b is a 4 to power a, which is a 1, giving us a 4. We're just referring to this operation, the rule for that operation. Roman numeral 2, they want us to find 2 operation 1 operation 4. So you can clearly see that if we go back to the use of body mass, you remember the body mass, brackets of division, multiplication, addition, and subtraction in that order. So we see we have brackets here. So we always have to first consider the brackets. So I'm seeing that I already have this done here, but if I didn't have it, then you have to first find this using this procedure. After getting the bracket, then you bring it back in a form like 2, 1 operation 4 is equal to, after working out this, now what is this? We say we got a 4. It is a 4. So we apply the same rule because the rule has not changed, because the sign here is still the same as this. So we are using it again here. So we compare, this is now our A, this is our B. So when we use the rule which says that A operation B is equal to B to power A, then that is our B is a 4 to power A, which is a 2. So this one gives us a 16. As simple as that. And looking at part 3, 2 operation 3. This one is equal to, this is our A, this is our B. So we say the operation says when you have such a thing, then it is equal to B to power A. This is the operation. So B is 3 power A, which is a 2. So this one gives us a 9. So that is basically what we do. Always relate what is given to the rule, okay? And then just try to rewrite this, but with the numbers that are given, okay? Find out what is your A, what is your B, then substitute here in the same operation. If it is given this form, first work out what is in the bracket, then bring it back in this form, okay? Because we cannot, the operation is only on 2 numbers. We cannot relate 3 numbers. So first work out these 2 to give you 1, then bring that 1 there, then also now they have become 2, work out the 2 and you get the final answer. Maybe lastly, let's look at this one here. Question 4. If you have an operation maybe A, now let's use this arrow pointing up, defined as A over bar plus B over A. So find 1, so it's a 2, it is a 2. So how would we find this? We do the same, compare, this is your A, this is your bar. So when we substitute back here, our A is 1 over our B, which is a 2, plus our B is a 2 over A, which is a 1. Then you simplify that fraction, and you see we shall have the all same as, maybe, or we can say this is equal to 1 over 2. You can make the denominators the same. It's the same as 4 over 2. I've just multiplied by 2 here, by 2 here, just to make the denominator 2. So when we have the same denominator, we can just add the power, the numerators. So we have 1 plus 4 over 2, which is 5 over 2, giving us a 2 whole number, 1 over 2. And that is it. Thank you for watching. Don't forget to subscribe, share this content to whoever may be in need of it. See you then.